Hello everyone, this is Mr. Underkoffler, and today we're going to be looking at the guided notes called multiplying and dividing integers. Alright, follow along with me. I think you're going to find these rules to be a lot simpler than what it is to add or subtract positive and negative integers. When you multiply or divide, so yes, these rules are going to work for multiplication and division, exact same rules. When you multiply or divide two integers with different signs, meaning one of them's negative, the other one's positive, and it doesn't matter which order, the answer will be negative. Doesn't matter who has the bigger absolute value. It does not matter who has the bigger absolute value. Now, when you multiply or divide two numbers with the same sign, either they're both positive or they're both negative, then the answer will be positive. Now, you might be like, Mr. Underkoffler, how do these rules make sense? Okay, let me show you a little something. From your Reveal Math textbook, page 150, they show you here an example of 5 times negative 7. Now, you should remember, the 5 was next to the parentheses with nothing in between, so that means times. So this is not 5 minus 7, this is 5 times negative 7. And what that really means is 5 groups of negative 7. When you think of 5 times something, it's really that something added to itself 5 times. So this 5 times negative 7 is 5 groups of negative 7. So negative 7, another negative 7, another negative 7. It just keeps going to the left 7. Well, that's obviously going to leave you at negative 35. And this is what mathematicians discovered way back centuries ago with a positive times a negative. It has to be a negative because it's really just 5 groups of that negative, putting you deep into the negatives. Now, to explain why a negative times a negative is a positive, this is going to be a little bit trickier. So let's start with some examples that we already know. How about 2 times negative 3? Well, we just learned that's going to be a negative 6. What about 1 times negative 3? Okay, that's going to be negative 3. 0 times anything is 0. That we know. Now, do you notice there's a pattern here? I keep multiplying by negative 3, but the number I'm multiplying to begin with keeps going down by 1. So it was 2, then it was 1, then it's 0. If I continue in that pattern, the next thing I would multiply by would be negative 1. And what I would multiply by that afterwards would be negative 2. There's also a pattern over here. This goes up by 3. This goes up by 3. So mathematicians centuries ago discovered if I follow this pattern, this has to keep going up by 3, which puts me now into the positives, proving a negative times a negative has to be a positive. Here it is again. If I follow the pattern again, it goes up by 3 again. Then a negative 2 times a negative 3 has to be a positive 6. So that's why these rules actually make sense that are at the top of your page. Okay, back to your guided notes. Pencils in your hand. Now, I did number 1 and I did number 4 for you. Take a look at them. Negative 5 times 3, different signs. This is negative, 3 is positive, so the answer is guaranteed to be negative. Pencils in your hand, let's do number 2 together. 16 times negative 4. Hopefully you remember, when there's nothing in between a number and parentheses, that means times, even though I didn't put a times dot. Now, you might not have any clue what 16 times 4 is. So I did the side work for you. 6 times 4 was 24, carry the 2. 1 times 4 is 4, plus 2 is 6. Will the answer be positive or will it be negative? Well, we learned at the top of the page. If you're multiplying two numbers with different signs, whether it's a negative and a positive or a positive and a negative, that final answer will guaranteed be negative. It does not matter who had the bigger absolute value. So I don't care that 16 was positive and had a bigger absolute value. I don't care. When you're multiplying two numbers of different signs, answer's always negative. And the same rules apply for division. We know 28 divided by 7 is 4. Since the 28 was negative but the 7 was positive, they had different signs. Guarantees the final answer is negative. All right, problem number 4. Further to the right on your page. A negative times a negative. We just learned that is a positive. And the same thing applies to division. 585 divided by 13. Now, I did the side work for you. You're like, thank you, Mr. Underkoffler, because this one was a little bit annoying. I already figured out how many 13s fit into 58, and that was 4 of them. 4 times 13 gave me 52. I subtracted and got 6. I brought down the 5, and then I asked myself, how many 13s went into 65? That was 5 of them. 5 times 13 gives me 65. You subtract and you get 0. All right, so we know this is going to give us 45. Should it be positive or should it be negative? Well, we just learned. If you're multiplying or dividing two numbers with the same sign, that answer will be positive. Do you have to put a tiny little positive symbol? No, you do not. But there you go. All right. Let's have you try 6, 7, 8, 9, and 10 on your own, practicing the rules that you learned from the very top of the page, which again is not just for multiplication, but also applies for division. So hit pause now, do 6, 7, 8, 9, and 10 on your own, then hit play when you're ready to see how you did. All right, I'm assuming you already did 6, 7, 8, 9, and 10. If not, you better hit pause now. 63 divided by negative 9, different signs, so it's going to be negative 7. But on number 7, it's a negative times a negative, same signs, so that answer is going to be positive. Problem number 8, you might not know what 24 times 3 is off the top of your head. 4 times 3 is 12, carry the 1. 3 times 2 is 6, plus 1 is 7. So this gives me 72. Should it be positive or negative? Since this is a negative times a positive, different signs, that's going to give you a negative answer. Problem number 9, I do not need to do long division side work when I divide by 25s, because 25s are like quarters. We know 4 quarters would make $1. So how many quarters would make $1.50? That would be 6 quarters, because 2 quarters makes 50 cents and 4 quarters makes $1. So $1.50 would be 6 quarters. Now, should it be positive or should it be negative? A negative divided by a negative. Oh, same signs. That's going to give you a positive. And finally, problem number 10. I like dividing by 11. And you can see this number up here looks like 11, but has a 0 at the end. So there is a cute little trick here. We know 11 divided by 11 is 1. Tag on a 0 at the end, and that's going to give us 10. No long division is really required here. It's okay if you did do long division, but you don't really have to. Should it be positive or should it be negative? Well, the number on top was negative, but the number on bottom is positive. Different signs. Answer should be negative. All right. What about, though, when we are multiplying 3 or more numbers? Follow along. If you're multiplying 3 or more numbers and there's a combination of positives and negatives, then you're probably going to want to multiply 2 numbers at a time so that you don't lose track of what sign each result will end up being. Now, having said that, there is a shortcut that can help you a little bit. If you are multiplying an odd amount of negative numbers, I can guarantee you the answer will be negative, and I'll show you why on some examples coming up. If you're multiplying an even amount of negatives, then your answer will be positive, and I can show you why on some problems coming up. But before I do, little side note over here, a little box on the right side of your paper, the rules I just talked about, how an odd amount of multiplication of negatives is going to give you a negative answer. An even amount of negatives multiplied together will be a positive answer. Those same rules can apply to exponents, because exponents is just like multiple multiplication. So a negative number to an odd exponent will be a negative. A negative number to an even exponent will give you a positive. All right, let's do a problem together. Problem number 11. Pencils in your hand. We got negative 12 times 3 times negative 2. So I'm not using times dots. I'm just putting parentheses next to each other to show the multiplication. A negative times a positive, different signs, gives me negative 36. Now notice I only am doing 2 numbers at a time. And then I'll bring down the negative 2. And now I have a negative times a negative. They are the same sign. So that's going to give me a positive 72. And if you didn't know this was going to give you 72, you would have went off to the side. 6 times 2 was 12. You'd carry the 1. 3 times 2 is 6 plus 1 is 7. Now, remember what I told you just above here. If you have an even amount of negatives, your answer will be positive. Well, we had 1, 2 negatives at the beginning. That's an even amount of negatives. And there's your proof. Look how it gave you a positive. There it is. All right, so now that I did number 11 for you, you're going to do 12, 13, and also at the bottom, 14 and 15 on your own. Now, don't forget to use the little reminder box that I gave you for exponents to help you out with those two exponents problems. All right, hit pause now. Do 12, 13, 14, and 15 on your own. Then hit play when you're ready to see how you did. All right, did you already do 12, 13, 14, 15 on your own? If not, you better hit pause now. All right, I decided to be creative here. I took these two numbers multiplied to each other, and then I multiplied these two numbers to each other because there's this thing called the commutative property that says you could switch the order, and there's this thing called the associative property which allows you to group numbers together however you want with multiplication problems. So in other words, you can multiply in any order you want if the problem is all strictly multiplication, which is what we have here. So a negative times a negative that I highlighted for you in yellow, that's positive 7. Oh, I lied. I did not actually multiply numbers by 2 grouping. You could have. I don't know why I didn't. I guess here I did 7 times 3, which is 21, and then 21 times negative 8 will put me back to a negative 168. But you could have done 8 times 3 and gotten 24. That would be negative 24. And then negative 24 times positive 7 would have given you negative 168. So if you showed your work differently, that is fine if you still got the same answer at the end. And again, we had 1, 2, 3 negatives. That's an odd amount of negatives. And look, your final answer was negative, just like I told you would be if you have an odd amount of negatives that you're multiplying together. All right, problem number 13. Oh, finally, this time I did what I was saying I was going to do on number 12. I multiplied these two numbers together, got positive 30, and then I multiplied these two numbers together and got positive 18. Notice an even amount of negatives. 1, 2, 3, 4 negatives. I'm going to end up with positive answers at the end. 30 times 18. You might not have any idea what 30 times 18 is. Here's a little trick. I don't know if you were taught this back in elementary school or not. If you multiply by a number that ends with a 0, you can just drop that 0 straight down. And then multiply everything else by the 3. 3 times 8 was 24. I carry my 2. 3 times 1 is 3 plus 2 is 5, giving me 540. Now, could you multiply in a different order than what I did here? Yes, you could, but you still should get positive 540 in the end. And remember, an even amount of negatives gives you a positive, whereas an odd amount of negatives will give you a negative if you are multiplying or dividing. All right, problem number 14. Let's use that same rule I just talked about. An even amount of negatives, you are going to get a positive. Now, 8 times 8 is 64. If you accidentally had 16, you were accidentally thinking that this was 8 times 2, but it is not. This is actually negative 8 times negative 8. That's what this actually means. And that's why it is positive 64, not 16. All right, what about negative 2 to the 5th power? Okay, let's do this together. 2 times 2, I'm actually using my fingers here as I'm recording this video. 2 times 2 is 4, times a third 2 is 8, times a fourth 2 is 16, times a fifth 2 is 32. But since it's an odd exponent, boom, this is going to be negative 32 because an odd amount of negatives multiplied together will give you a negative answer. Now, little box at the bottom here. Don't ignore this. You might want to put some stars around this because details matter. When you write a negative number taken to a power, meaning exponents, you must write the negative in parentheses and the exponent outside. Now, that's written like this. The negative is in parentheses and the exponent is outside. That is the official way of showing a negative number to a power. You're like, why do I need the parentheses? Here's why. If you don't have parentheses, order of operations would actually have you do the 4 to the second first, which would be 16, and then the negative would be brought down onto that final answer. So this is really 4 to the second, then made negative, which is not the same thing as taking -4 times -4, which is what this means when you put it in parentheses. This would actually mean -4 times -4, which of course is positive 16. So, moral of the story, if you're going to show a negative number taken to a power, you must put the negative number in parentheses and write the exponent on the outside. Okay, turn the page. 16, 17, 18, 19. You can see what the directions are telling you. They are giving you the values of the variables. All you're going to do is rewrite the problem, like here, a over c. I see a is -24, I see c is 6. So I write it with no longer having variables, replacing those variables with the numbers they equal from the directions, and then you finish the problem. We might as well finish this one together. -24 divided by 6. 24 divided by 6 is 4. Since they're different signs, that's going to stay -4. All right, hit pause of the video, do 17, 18, and 19 on your own, and then hit play when you're ready to see how you did. Okay, did you already do 17, 18, and 19 on your own? If not, you better hit pause and do these problems on your own. And we should, by the way, we should not be using a calculator. I should have mentioned that at the beginning of the video. Hopefully you already have not been using a calculator throughout this entire integers unit. Okay, here we go. Let's rewrite the problem. We have -5. Oh, did you remember to put it in parentheses? If you did not, get your pencil in your hand right now. This is the only correct way of writing a negative number to an exponent. The negative number must be in parentheses and the exponent is on the outside. Then times 6. If you also want to write the 6 in its own set of parentheses instead of putting a times dot, yes, you could do that. That's the other way of showing multiplication. All right, order of operations says you better do the exponent part first. So this is 5 times 5 times 5, but it's negative. Let's think about this. 5 times 5 is 25 times another 5 is, oh, that's the other part, is 125. But it's negative because, as I told you, an odd amount of negatives will keep the result negative. Now, let's take -125 times 6. 5 times 6 is 30, carry the 3. 6 times 2 is 12, plus 3 is 15, carry the 1. 6 times 1 is 6, plus 1 is 7. Different signs, so it is -750. Problem number 3. We have -c. c was 6, but now it's -6. Remember, keep it in parentheses, taken to a power. -6 to the second means -6 times itself. That is, whoa, this is an error. Mr. Underkoffler, your guided notes are wrong. Why did you not proofread this? Positive 36, because it's an even exponent. Then 3 times 36, you know what, this means my answer is going to be wrong. I should have proofread this. Sorry about that. Okay, just shows you Underkoffler's not perfect. We all make mistakes. 6 times 3 is 18, carry the 1. 3 times 3 is 9 plus 3. Carry the 1. Underkoffler, another mistake. This should be a 1. 6 times 3 is 18, carry the 1. 3 times 3 is 9 plus 1 is 10. Oh, I did have the 10. This should have been a 1 though, not a 3. Okay. No, the answer is not negative. No, no, no. Fix this. This should be a positive. Sorry, that positive symbol got a little crazy there. All right, let me make that a little bit better. Forgive me for that. Errors by Underkoffler. Okay. Where was I? Problem number 19. Hopefully this one is not wrong. C to the third is 6 to the third, and we got that over -4. Okay, exponents first, and it's the numerator of the fraction, so we're going to do that first. 6 to the third. 6 times 6 is 36. 36 times 6, probably not going to do this in my head. 6 times 6 is 36. Carry the 3. And then 3 times 6 is 18. Plus 3 is 21. So that's 216 over negative 4. Oh, let's do some long division. Can 4 go into 2? No, it cannot. Can 4 go into 21? Yes, it can. 5 times 4 is 20. Subtract you will get 1. Bring down the 6. How many 4s can fit into 16? 4 of them. Now we're going to take 4 up here times 4 out here, and that's going to give me 16. We will subtract, giving me 0. Yay! All right, 54. Should it be positive or should it be negative? Well, 216 was positive, 4 was negative. Different signs, so that's going to give me negative 54. All right, we got some word problems at the bottom of the page. 20, 21, and 22. I will do one of these with you, and I'm actually going to do 21. So we're going to skip 20 for now. We're going to move down to 21. Make sure that you are looking at the correct problem here. This is number 21, not 20. It's the problem that talks about Natalie. Natalie had $165 in her bank account at the beginning of the summer. Over the next 10 weeks, she worked at the summer camp and added $160 to her savings each week while spending only $40 per week. Once she gets back to school, she plans to spend $105 per week. How many weeks can she make withdrawals until her balance is $0? Okay, that was a lot to read. Well, first of all, we know that she had $165 in her bank account to start with, so let's go ahead and write down $165. Now, over the next 10 weeks, she's adding $160 to her bank account, but she's spending $40 per week. Now, did you catch that we have some words here that we talked about earlier this year that can mean multiplication? Each week means times the weeks, but here it's per week, which also means times the weeks, and we know it's 10 weeks. So, we should also talk about how savings money, that is going to be added, that's positives, but spending is going to take away the $40. So 160 is positive, but we're taking away $40, and this is being done per week for a total of 10 weeks. So it's going to be 10 times whatever 160 is, take away 40. Now, this is not the only way of doing your work. You could do 10 times 160 minus 10 times 40. That would also work. This is the way, though, that I'm deciding to do it. All right, 160 take away 40 is 120. Then we're going to follow order of operations. I already did the parentheses first. Now we're going to do 10 times 120, which is just going to add a 0 on the end, making it 1,200. Finally, I get to add this to 165, and here's the cool thing. I don't really need to do side work. I can take 200 plus 100. I already know that 65 plus 00 is just going to be 65. 200 plus 100 is 300, so this is going to be 1,365. But I'm not done. She's going to be spending $105 per week. Apparently that's going to be her withdrawing the money, because that's what it mentioned in the next sentence. How many weeks can she make these withdrawals for her spending money? So, I know you might think withdrawals or spending is subtraction, but it's how many weeks can she continue to do this of taking away $105. So, if it's repeated weeks, then this is going to be a division problem. Now, there were no words that meant division. In fact, per week might make you think multiplication, but then it said how many weeks. If I knew the number of weeks, then 105 per week would mean 105 times the weeks. But I don't know the number of weeks, so that's why it's the opposite, the inverse of multiplication, which is division. All right. Do you know what 165 or 1,365 is divided by 105? I don't. So I'm going to do some long division. Now, to do long division, I ask myself, can 105 fit into 1? No. Can it fit into 13? No. 105 is bigger. Can it fit into 136? Yes, it can. And only one of these 105s can fit into 136. So 1 times 105 is 105. Make sure you line it up underneath the 106. Don't line it up underneath the 5. 136 minus 105. 6 minus 1 is 1. 6 minus 5 is 1. 3 minus 0 is 3. This is going to give me 31. I will now bring down the 5, and now I'm going to ask myself, how many of these 105s will fit into 315? Well, you probably thought to yourself, if I had 100 exactly, and this was 300 exactly, 100 times 3 would make 300. Yeah, that's a good way to think about this. 3 of these 105s can fit into 315. So let's take 3 times 105. Now, how do I do that? 3 times 5 would make 15. And then 3 times 0 is 0. 3 times 100 is 300. So this is going to give me 315. Subtract, I get a remainder of 0. So the answer to the question is 13 weeks is how many weeks she can continue to withdraw $105 per week until her balance would eventually be 0. Okay, now that I did number 21 for you, I'm going to want you to read number 20 and number 22 on your own, and here's the deal. I cannot guarantee you that these are division problems. Maybe they are, maybe they're not. Maybe multiplication makes more sense. You have to figure it out. You have to read the problem, figure out what's going on, even figure out if there's any addition or subtraction involved before you just do the problem. So take your time, do 20 and 22 on your own, hit pause now. When you're done with those two problems, hit play to see how you did. Okay, I hope you already did 20 and 22. Let's see how you did. Expenses are negatives, but revenue is positive. So I'm going to add these negatives together and then eventually positive for the income. These negatives added together are going to give me, well, I would do some work off to the side. 2 plus 2 is 4 plus 7 is 11. Carry the 1. 1 plus 3 plus 3 plus 1 is 8. Oh my goodness, Underkoffler, fix your guided notes. This is 81. Wait a minute. No, I messed up. This is supposed to be 12 here, not another 32. So 1 plus 3 plus 1 plus 1, that actually is 6. So forgive me for my typo there. Okay, that's going to give me negative 61, because when you add negatives together, the answer stays negative. A negative plus a positive, you will subtract in your head. That will give you 64. Now, he's doing this for 20 weeks. So you're going to have to multiply this by 20 to find out how much money he's going to earn after those 20 weeks. And you probably don't know what that is off the top of your head. So use the trick I showed you earlier. If it ends with a 0, you can drop that down. Then you can take 2 times 4, which is 8. 2 times 6, which is 12. That's going to give you $1,280 after 20 weeks. All right, finally, number 22. The best underwater divers can dive 380 feet in 4 minutes using only a rope as they descend. What integer represents the change in feet after 1 minute? So they gave me the time in 4 minutes, but I need to know what it is in 1 minute. So I'm going to have to divide by 4. This is basically a unit rate problem that you've done before in the past. But watch out. He's descending 380 feet in the water. So you really should write this as negative 380. Get your pencil in your hand. If you didn't have the negative sign, get it on there now. Negative 380 divided by 4. Now, what is that? You went off to the side. Can 4 fit into 3? No. Can it fit into 38? Yes. 9 times. 9 times 4 is 36. Subtract, you get 2. Bring down the 0. How many 4s can fit into 20? 5 of them. 5 times 4 is 20. Subtract remainder of 0. But Since we were dividing two numbers with different signs, that's going to stay negative, and that is the integer that represents the change in feet of the diver's position after only 1 minute. Negative 95 feet per minute. All right, that concludes the guided notes on multiplying and dividing integers. Thank you for watching. We'll see you next time.